All right, let's go over the notes on covalent bonds. Covalent bonds mean, by definition, means that the electrons are being shared. Unlike when we were just talking about ionic bonds, where one atom gives up that electron and gives it to another atom. Right? So this one right here lost the electron, this one right here gained the electron, and you end up with a positive charge, negative charge, and that's what pulls them together because they have opposite charge. That's ionic. Right? Now we also talked about metallic bonds, where you have all metal ions, right, or metal atoms, and that those valence electrons are going in between all of them, and that's what's holding them all together, and that's how we get metals like copper wire. That's how iron is held together, that holds your car together. Anything that's made out of metal, that's how it's being held together, which is hard to imagine, to think that all it is that those valence electrons is zigzagging in between those atoms to try and hold it together. So now we're to the third type. The third type is called a covalent bond. Covalent bonds are for molecular compounds. And oh my goodness, now again, it's like you have to think way back. Well, what's a molecular compound? That's an atom, or I'm sorry, that's a molecule that's made up of two nonmetals, right? Which means it's made up of two of these guys up in this corner of the periodic table. All right, things like carbon dioxide, carbon monoxide, water. Those are all molecular compounds which utilize covalent bonds. Now, what happens in a covalent bond? The two atoms are going to share the electrons. So the electrons are going to go halfway in between. They're going to go back and forth. All right. They're not going to go all one direction. It's not going to go all the other directions. It's just going to sit there and go back and forth, and that's what holds them together. All right. So in order to do this, according to your notes, we're going to look at the first one, which is a single covalent bond. And there's a rule that you need to know, which is called the octet rule. And the octet rule, we've kind of been talking about this periodically throughout this course. And the whole idea on that is that you're trying to get 8 electrons. All right? That's what they're always trying to get. Why do they want to get 8? Well, they want to look like these guys over here. Right? Those noble gases. And the noble gases have 8 electrons in their outermost ring. They have 8 valence electrons. Exception, helium, he's got 2. Right? But all the rest of them have 8. And that's what they're trying to look like, is those. So what these guys are going to do is they're going to share electrons to try and get 8 valence electrons. The exception again says hydrogen he wants to share to get 2 because he wants to look like helium. So by definition for a single covalent bond is it's a pair of electrons being shared between 2 atoms. Now it's time to do a diagram. And according to your notes it says see the lecture to get the diagrams. Well, what we're going to do is we're going to look at making H2. So if I do the electron diagram for H, he's got an H with 1 dot, and then we got an H with 1 dot. All right, and let's see if we can make this so you can see me instead of just seeing. There we go. Okay. So what's got to happen here is now H. Remember, he wants to have 2. Right. Now remember, this is the exception to the 8, but this is where we're going to start at. So this guy could give it over here, and then he would have 2, but then this one right here would have none, and that just doesn't work in this case. So really what ends up happening is you get both of these, and they share it in between. And the way in which I like to describe this is look at it this way and go, okay, this guy now has 2. Those are his electrons, but also these 2 are going for him also. So I'll use something that you've used in English and think of the idea of a Venn diagram. That's what this looks like. Now, when these things that are in the middle of a Venn diagram, what's happening to them? It's something that both sides share, right? So that H on this side, he's sharing those electrons. The H on this side, he's sharing those electrons. Right? Now, if we look at going back to the idea of the off-ball diagram, right? This guy over here, he's got 1 electron inside that box. That's a 1s1. And this hydrogen over here, he's got 1 electron, and that's a 1s1. And when they both go together, we end up with a 1s2, which means I have 2 electrons inside that box, right? And those representing these guys up here, right? Now we can also diagram this structurally and go, well, these 2 electrons here, if I draw a line in between them, right, that can represent those 2 electrons. So we can do this structurally and do that. And that bar that's in between, that counts for 2 electrons that are being shared between the 2 hydrogen atoms. Right? So a single bar, 1 single bar means a single covalent bond. And that's actually 1 pair of electrons or 2 electrons. Right? And that's what's also in your notes down there. So those are the parts that you need to add to your notes That are the diagrams. So now let's go to a double covalent bond. So we're going to get rid of this. So remember, single covalent, all it is we're sharing one electron. Now we're going to do carbon dioxide. Double covalent means we're going to share two pairs, so 4 electrons. So we go carbon dioxide. So they have carbon, he's got 1, 2, 3, 4. Right? And then we got oxygen. Now there's a little rule of thumb that you can use almost all the time. It's not perfect every single time, most of the time. And that is, because I got 3 of them, something's got to be in the middle. Okay? Rule of thumb, the one that's got the least number goes in the middle. Okay? So carbon's only got 1, oxygen's got 2 of them, so therefore the carbon's going to be in the middle. So we're going to put an oxygen over here. Oxygen has 6 valence electrons, so here's his 6. And I'm going to at least do a single covalent bond between these two. Then we'll do the other oxygen over here. There's his 6, and he's got a single covalent bond there. Okay. And if I do my circles here, just to see, here's the carbon in the middle. And then we do this one. There's the oxygen. And here's this oxygen. So now we have to do is now get count up how many valence electrons do they have now. So if we look at add up the carbon, he's got 1, 2, 3, 4, 5, 6. He's got 6 of them. This oxygen over here has got 1, 2, 3, 4, 5, 6, 7. This oxygen over here has got 1, 2, 3, 4, 5, 6, 7. So none of them are happy. None of them have 8. So what we're going to do is we're going to take this and we're going to move this over here. And we're going to take this one and put it there and make this into a double bond. Double bond meaning that I'm sharing 2 pairs or 4 electrons now. Now if I do this circle, he's got 1, 2, 3, 4, 5, 6, 7, 8. Sweet, that oxygen's good. What about the carbon in the middle? He's got 1, 2, 3, 4, 5, 6, 7. He's still not good. But if we go to this side, we can take this one, put him over here, take this, put it there. Now this oxygen on this side's got 1, 2, 3, 4, 5, 6, 7, 8. This guy over here's got 1, 2, 3, 4, 5, 6, 7, 8. Now what about the carbon in the middle? 1, 2, 3, 4, 5, 6, 7, 8. Everybody's got 8, so these guys are all happy. So what does this look like structurally? Well, we have a carbon that's double bonded to an oxygen and double bonded to this oxygen. Okay. Now the other piece I also want you to know is we do have these pairs of electrons that are not being shared, and we should actually place them out here. And that's all those little bars mean, is means I've got some electrons that aren't being shared. Okay. Now notice where I placed them, they kind of get pushed away so they're far away from each other. Okay. They're not really here and here because that would put them too close to these center ones. They actually get bumped so that they're farther away from each other. So that's a double covalent bond. All right. Now let's go to the triple covalent bond. And for this one, we're going to do N2, or atomic nitrogen. So if I do this, we got 1 nitrogen, he's got 5. There's 1 nitrogen. We're going to have him bond to another nitrogen, who's got 5. There's his 5. Now let's do my circle. There's the 1 nitrogen. Here's the other nitrogen. There's the ones that are being shared in between. How many does this nitrogen have? 1, 2, 3, 4, 5, 6. How many does this guy got? 1, 2, 3, 4, 5, 6. All right. So let's bring these guys in. Double bond. Now he's got 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. They're still not happy. So let's bring this guy down and this guy down. Now we got 1, 2, 3, 4, 5, 6, 7, 8. This nitrogen's got 1, 2, 3, 4, 5, 6, 7, 8. So now they're both happy. So now if I do my, make it structurally, this is a triple bond. There's 3 pairs of electrons being shared. And with this nitrogen, then I also have some unbonded pairs of electrons on the ends. All right, so that's the concept of a single bond, double, and a triple covalent bond. And again, remember the idea is they're being shared in the middle here of this, which if you want to call it a Venn diagram, we don't call it a Venn diagram in chemistry, but if that helps you, visualize that that's what it is, that's fine with me if that helps you think of how it works. And remember that the ones in the middle are being shared. All right, so now the other thing that's on your notes that talks about why are some molecules not linear? So we're going to do H2O. Now, if you remember my little rule of thumb earlier, I said the one that's got the least number is going to be the middle.
Following students to the high school office, please. Daniel Rodriguez, Zachary Brooks, Allison Kramer, Jason Hennigan to the high school office, please.
Okay, so hydrogen's got 2, oxygen's got 1, so that means the oxygen's going to be in the middle. So he's got 6. There's his 6 electrons. Now let's bond him with a hydrogen. This one over here, and he's got 1. That gives him a single bond. Hydrogens can only do a single bond because they only got 1 electron to use. And then we're going to do this guy. All right. So it looks like this should be a straight line molecule, but it's not, because what ends up happening is these non-bonded pairs of electrons, they actually try and move closer to each other, and it pushes this H down. So what we end up with, instead of it looking like this, it's going to look like this. Whoops, wrong shape. So we end up with this, and we end up with a bent molecule, so that this water molecule is actually bent. It's not the straight line. And again, why? It's all because of these non-bonded pairs of electrons, and those take it and go and push it down and give it a bent shape. So that's why we end up with a bent shape for that molecule. All right, we're going to stop there for a minute. We're going to go to part number 2. We'll see you in part number 2 in a minute.